This is section 14.5 on related rates. And so now we're going to use what we learned in 14.4. We learned a method called implicit differentiation, and we did everything in that section with respect to x. We're going to do a little bit differently now. So just a couple of steps that I would want to think about. On related rates, you want to draw the picture of whatever is going on in your story. Write down the given info. In other words, whatever you're given in the story, in the problem, you want to write that down. And then write what you're asked to find. It's usually going to be a rate, so it would be some sort of DT, because everything should be that we're going to deal with is probably with respect to time. So keep that in mind. We're going to write a formula or an equation that relates variables. So we'll do that. In other words, if we're talking about area of something circular, we would have pi r squared. If we were talking about a cost function, they probably would give that to us. So we'll write a formula or an equation. Then we'll use implicit differentiation to solve, and then we'll evaluate. So just keep in mind these steps as we go through our problems. So let's go to our problems and practice. So this one says, assume x and y are functions of t. Evaluate dy dt. So that's the derivative with respect to time of your y variable for this function with the conditions. And so they've given us a few conditions. So they've given us that dx dt is negative 18, x is 6, and y is negative 1. All right, so we want to start by taking the derivative of this function. I'm going to write that function right here. 3xy minus 2x plus 6y cubed equals negative 36. And we can tell this is a crazy function. It's not in y equals form, so we're going to use implicit differentiation. We also need to know that this is a product. So we have to think about that as we write this down. So 3x times the derivative of y, which is 1 dy dt, because everything is going to be with respect to t, plus y times 3 dx dt. That's different than what we did before. So that's this piece. Minus 2 dx dt plus 18y squared dy dt equals, and the derivative of 36 is 0. All right, so we've got all that. Let's kind of clean this up, gather things together. So we got 3x dy dt plus 3y dx dt minus 2 dx dt plus 18y squared dy dt equals 0. All right, so it says evaluate this with these conditions. So we're going to go through and we're going to plug in these numbers. So we've got 3 times 6 dy dt. We don't have anything for that. We're supposed to be trying to find that. Plus 3 times y, which is negative 1. Dx dt is negative 18. Minus 2 times negative 18. Plus 18 times negative 1 squared dy dt equals 0. So I took the things that were given up here in the problem and plugged in everything that we were given into here, and now we'll just kind of clean that up a little bit more. So this is 18 dy dt plus 54 plus 36, and negative 1 squared is 1, so this is plus 18 dy dt equals 0. So now, of course, if we're solving for dy dt, so now we've got to combine the things that have dx dt and dy dt rather. So I've got 18 and 18, so that's 36 dy dt equals, and I'm going to move these two over, so that's a negative 90. Then I'll divide by 36, so dy dt is equal to negative 90 over 36, which reduces to negative 5 over 2. And that would be our answer for that one. All right, number 2 says, find the rate of change of total revenue, cost, and profit with respect to time. So remember, that's going to be the dt. Assume that Rx and Cx are in dollars. So here is our cost function, our revenue function. Here is our cost function. And then we've got some parameters. We've got x is 30 and dt is 20. All right, so they want to know the rate of change. So they're talking about a derivative here for all of these. So R of x is equal to 55x minus 0.5x squared. Let's take the derivative of that, and what we want to write over here, this is dr dt equals 55 dx dt minus 1.0 x dx dt. So that is the rate of change function. So now we're going to plug in the things that we have. So we have 55 times 20, because that is dx dt, minus 1, x is 30, dx dt was 20. All right. So 55 times 20 minus that, and we should get 500. So dr dt is 500. That is the rate of change of the revenue. All right. Then we're going to do the cost. And the cost function we were given was 2x plus 20. So dc dt is 2 dx dt, and then the derivative of 20 is 0. So we're going to plug in. So dc dt is equal to 2 times 20, which is equal to 40. And 40 is the rate of change of the cost. All right. And then the last part of that question says, what's the rate of change of total profit? Well, remember, revenue minus cost is profit. So if we take 500 and subtract the 40, we get 460, which is going to be our rate of change for the profit. Okay. All right. Okay, number 3, the brain mass of a fetus can be estimated using the total mass of the fetus by the function. It gives us this function here, where m is the mass of the fetus in grams and b is the brain mass. So you're talking about the mass of the fetus and the brain mass, and how are those connected? Suppose the brain mass of a 22-gram fetus is changing at a rate of 0.21 grams per day. Use this to estimate the rate of change, the total mass of the fetus, dm dt. All right, so what are we given? We're given this function, okay? We got b equals 0.22 m to the 0.87, all right? So if we're going to take the derivative of that, we've got db dt equals, now multiply 0.87 times 0.22, and you should get 0.1914 m. If you take 1 away from this, you get negative 0.13. So that's the derivative of that. and it's dm dt. All right, so what were we given? What were we given in our problem? We were given that the brain mass is changing at a rate of 0.21 grams per day. So that is here. That's the brain mass. So we're going to put 0.21 here equals, and I'm going to go ahead and I'm going to put 0.1914, and then the mass that we were given was 22 to the negative 0.13, and dm dt is what we're trying to find. So typically that's what's going to happen. We'll take the derivative and then we plug in the things that we do have. So I meant to put that also in red. All right, so 0.21 equals 0.128063 dm dt. Let's go ahead and divide both sides by this number. And so we have 1.63981 is equal to dm dt. And that is what we were asked to find. Use this estimate to find the rate of change of the mass, which was dm dt. And keep in mind, every time we take a derivative, we're going to have a dt. So this was b, that became db dt. This was mass, dm dt. All right. Let's go here to number 4. All right, suppose the average daily metabolic rate for certain types of animals can be expressed as a function of mass by R equals this, where m is the mass of the animal and R is the metabolic rate. If the mass of an animal is changing at a rate of dm dt, find dr dt. That's A. Determine dr dt for a 70 kilogram animal that is gaining mass at a rate of 2 kilograms per day. So let's write down a couple of things. M, we're talking about mass of the animal. And R, the metabolic rate. All right, so we're given that R equals 143.8 meters to the 0.075. Okay, that's what we're given. So let's take the derivative of that. That'll be dr dt equals 0.75. And you know, I think I put that 0 in the wrong place. That's 0.75. So 0.75 times 143.8 meters to the negative 0.25 dm dt. All right. So let's plug in, let's just do this number here. Dr dt equals 107.85 meters to the negative 0.25 dm dt. That's A part. That's in general. All right. In B part, dr dt equals 107.85 times a mass of 70 to the negative 0.25 times dm dt of 2. Let's make sure we see. So they said 70 kilogram animal and a metabolic rate of 2. So I plugged in both of those numbers, and then it's just a calculation. So dr dt equals, when you do all of this in your calculator, 74.572. And I think it does say round to the thousandth, so that's what I did there, was round to 3 places. Okay. All right. Let's go down here. All right, number 5, a 20-foot ladder is leaning against a building. If the bottom of the ladder is sliding along the pavement directly away from the building at 1 feet per second, how fast is the top ladder moving down when the foot of the ladder is 4 feet from the wall? So we've got a building here, and we've got a ladder that's leaning up against it. So the ladder is 20 feet. So we could say that's 20. And let's just go ahead and call this X and this Y, because here's our ladder. It's how far away when we're talking about this is going to be 4. So when X is 4, we could do this. We could say when X equals 4, I'm going to have 4 squared plus Y squared equals 20 squared. So 16 plus Y squared equals 400. Y squared then equals 384. Take the square root, so we're going to put 19.596. So I'm going to highlight that because we found what Y would be if X was 4. Okay? All right, now let's think about another relationship here in this triangle. If you have a right triangle, we should remember that X squared plus Y squared equals 20 squared. That's Pythagorean theory. So let's take the derivative of that, because we're supposed to find how fast the top of this ladder is sliding down when this part is sliding this way. So we need this relationship. So we got 2x dx dt plus 2y dy dt equals 0. All right? And we're supposed to find how fast the top of the ladder. So we're looking for dy dt. Let's also write down this one is sliding, so that's dx dt was 1, and we are finding dy dt. All right. So let's go further here. Let's move this x term over here. So we got 2y dy dt equals negative 2x dx dt. Okay? Divide by your 2y. So dy dt equals negative 2x dx dt over 2y. I can simplify that a little bit and say dy dt equals negative x dx dt over y. And now we're ready to plug in. So we've got dy dt is equal to negative 4, because when x is 4, and then dx dt was 1, over 19.596. So when you do that in your calculator, you should get negative 0.204. That's the rate that is moving when the top of the ladder is sliding down at 1 feet per second or foot per second. Then the bottom of the ladder, when the bottom's doing the 1, the top is doing it at negative 0.204, and the negative is because it's sliding down. Okay, so that should be that one. All right, number 6, a rock is thrown into a still pond. The circular ripples move outward from the point of impact of the rock so that the radius of the circle formed by the ripple increases at a rate of 2 feet per minute. Find the rate at which the area is changing at the very instant that the radius is 7 feet. All right, so we've definitely got a circle and we've got a radius. And what are we given? We're given that the ripple, the radius of the circle, is increasing at a rate of 2 feet per minute, and that's a rate. So that's going to be dr dt is equal to 2. All right? And we're supposed to find the rate at which the area is changing. So we're supposed to find dA dt when r is 7, when the radius is 7. So what do we know about the area of a circle? We know that A is equal to pi r squared. Let's take the derivative of that function. dA dt equals, remember pi is a number, so 2 pi r dr dt. All right, let's plug in what we know, and we're trying to solve for dA dt. So dA dt equals 2 times pi. Now r we're given, and dr dt we have. So r was 7, and dr dt was 2. So when we do all that in the calculator, of course we get 28 pi, and then we'll do the equivalent, we'll do that on the calculator, and 87.965 I think is what we give. It says round to 3, and that's what we get. Okay? All right, last one. An ice cube that is 9 centimeters on each side is melting at a rate of 5 centimeters cubed per minute. How fast is the length of the side decreasing? All right, so let's think about it. An ice cube, which, you know, we used to have old ice trays that actually made cubes, but let's think about a cube. The definition of a cube is that all sides are equal. And so this would be 9 here, 9 here, and 9 here. And we need to think about, if it's melting, then what's changing is the volume. And it's doing it at a rate of 5 centimeters per minute. So we are given dV dt is, and because it's melting, it's deteriorating, -5 is what our dV dt. We're supposed to find the length of the side. How fast is it decreasing at the moment when the ice cube is 9 centimeters on each side? All right? So we are supposed to find ds dt when s is equal to 9. All right. So the volume of a cube is the side cubed. So that would be s cubed. Now let's take the derivative. dV dt equals 3s squared ds dt. And now we're going to plug in what we know. We're given dV dt, so that's -5 equals 3, and we want to put in 9 because that's the side, and ds dt is what we're solving for. So we have -5 equals 243 ds dt, and that ends up being -0.021 equals ds dt. And that's the rate that the side is decreasing. So I think that will get you going on the problems for 14.5.